Okay. Okay, let me just take off my headset. Okay, so I always make a disclaimer in the beginning of my videos because I messed up somewhere. And not only did I mess up on a recording thing or whatever, but I messed up on me making the disclaimer that I messed up on something. Because I have this weird audio bug that I have to play the audio through the voice mod so that the computer can hear it, or the computer is generating audio, and then my OBS is taking the desktop audio instead of my voice audio from my mic, because for some reason OBS is not having a fun time with my mic. In voice mod, it sounds great. So voice mod is picking up my mic perfectly well, as you're hearing right now. There's nothing on it. Or I don't have any voice changer on it, even though Cathedral is selected. I don't have any voice changer on it. But in OBS, it should be taking up the same audio that voice mod is, yet it sounds like I'm 10 feet away inside a tunnel, inside a trash can that is on fire. Like, it's just horrible. So, so then I made the whole video and everything. Sometimes the audio gets a little weird, so that was the disclaimer I was trying to make. But then I realized that this disclaimer that I just made, I turned off the voice mod thing, and so you couldn't hear anything. So hopefully now it works and everything, and so that's the disclaimer. And yeah, so anyway, enjoy the video. I'm done with the disclaimers. I always make them, but I should really stop. Anyway. Oh, and one last thing, or maybe one first thing. It depends on when I put this segment in to the video. I might even put it in the beginning, but I encourage you to check out my website. I actually made a website. It's using Wix, so you're always gonna have this like thing up here that says Wix, but I did not think Wix was so good at making websites. So I'm not sponsored or anything. Obviously, me being sponsored, are you kidding me? But this is surprisingly well done. So I'm not gonna go through the website. Maybe I'll make a video on that. But it's very professional to have a website, especially the type of career choice that I'm trying to go for. I'm trying to get into some sort of media thing, maybe gaming, or like art type thing, and like in the industry stuff. So it's nice to have a portfolio. And one of the not job offers, one of the jobs that I was interested in, that I filled out an application and everything, which I'm still waiting to get back on. Sorry, I just realized that I'm saying all this stuff, and if does go in the beginning, then it's like, wait a minute, this is totally not what I was trying to watch. Sorry, let me just say that. So I'm just gonna skip all that. Basically, I have a website. It's good to have a website, and there's a lot of different pages and stuff to go to. If you go to my work, that's basically the hub, even though home is like the hub. I got my art projects, and then I got my coding projects. So and then I also got my Scratch thing, so right here. So I don't have it in coding projects, but its own page in the more Scratch, and then you can see things I've worked on, little images and stuff, and then you can just click this and it goes to my Scratch page. Let me go back. But if you go to here, then this is the main thing. This is where all my art is and stuff, and so I got a lot of like everything here I've created. All this is like, Blender or hand drawn and stuff like that. Actually, majority is Blender, so CGI stuff. But quick plug, just check out my website. It would be really awesome. This is the first time I'm promoting the website, and I made it, like a month ago. Literally, no one else knows except for like my mom. So, yeah, check it out. Okay, so we're going to look at an API that I just made. It's called the Variable Memory API. And this API is basically a way to manage variables in Scratch that aren't the normal variables that are built in, but like a separate variable system. So these are the normal variables you use in Scratch. You also have the list variables, quotes around variables. And these two things you use to make your games, make your projects and stuff. But one of the problems with them is they are a little bit of a hassle to work with each time you want to make a new variable. So you can't make new variables inside the program. You can only declare them in the beginning before your project runs, and then use them after the project starts running. Same with the lists. So if you want to have a system that can create variables when the program is running, or if you just want like a fast way to store variables, well, it's going to be slower than this way, but it's going to be like a fast way to manage variables, and you'll see why. Then this is the API for you. So one of the cool things about it, if I go back to the page here, I used to have like a lot of documentation about how this thing works, but I kept adding functions, and it was getting annoying. So I just took it out, and I'm gonna make this video, so that you can. So you can see right here that this is where the video tutorial is gonna go when I'm finished with this. But yeah, I want to make this video so that it's like the official documentation for it, at least for now, for the 1.0 version. But yeah, right here it says that you can basically read and store 3 different types of variables: numbers, arrays, and strings. So if you ever work with JavaScript, that's the program I usually use to write programs in, or that's the coding language I use. And they use a lot of different variables. There's like float and integer variables and all these different things, but I just have number variable, array variable, and string variable, and I'll go through what those mean in a second. But the number one's pretty self-explanatory. It's just storing a number. The array is just like the lists. So these values here, or these variables and these lists, are the main, besides the console.log, these are the main, like, this needs to be here for this to work. If you want to have this project or if you want to have this API in your projects, you don't need to actually remix this page. You can just export this. This stores everything. This has there's nothing in the background or anything. This is just like image for the project, and everything's just in here. And then when you want to make projects, you just make everything inside the variable API. You can rename this to whatever. It will just be running in here, because if you go outside, if you look down at the blocks, the functions, when I leave, it'll go away. That's how Scratch works. So and then another thing is basically, well, let me get to that in a second. I'll worry about the variable types here. The variable types for the array variable type is basically this. Like if you know that, let me like make a new list, right? Or I could just add to the cache, and I'll talk about the cache and all that in a second. But if I like add that to cache, then if you read the cache, it'll be like this. And if I add another one to cache, you're gonna see like these spacings. So that's what this does, and this is pretty handy. Or like, you don't really use this when you're making a project, right? When you click on this, and you don't really put this inside anything, you know. But this is like a variable that stores the whole array, and that's what I actually use as part of the variable system. So if I can actually demo this, I'm going to take off the background for a second so that we can see the background, which is all white, so we can have something here. And what I'm going to do is I'm going to declare like a player thing. So I know I'm not making sense, but I'm trying to. Oh, whoops, not in here. Over in here. So when we start if you had this installed, let's say you start this project up and you're making a game or whatever, and let's say you have like a ball that has like physics around it, okay? This is how you could do something like that. So these are the functions that you want to use, and everything that has like z dot or zz dot, that's like the background functions. You never use these. It's only these that you're going to use, and it's really going to be this one and this one, the set and read functions. Let is also there for you. It's basically a faster version of set. Let will just look at all the variables that have existed in the memory and make sure that you can't create duplicates of the variable that you want to create, but that's it. Set will like clear that variable and put the variable in with a different value and all that. So there's a lot more steps involved with set. So if you can use let, then use let. But for the most part, you're going to be using set, which is going to set the value of a variable rather than just declaring the variable. So let's just use set for now, though. So it's simple. And let's say we want to set, we can set, like, let's say we name it ball. So this is going to be the variable name. It's going to be called ball. And this is where you set the type. So remember, there was array, there was number, array, and string. Now, by the way, string is like a word, and number is a number. And in this API, it's basically the same thing. Number and string are like the same thing in here. I find the store type right here, this is what's actually storing the value based on the value type. And if you look at number, it just adds it to the spot it needs to add it to. And then if you look at string, it's the exact same thing. If you don't put number, array, or string inside the value type, then it just doesn't do anything. It's right down here. I actually can add like a little thing here to report. So if I add this is why I have the console.log. This is just to report errors and stuff. But I can say that like, where's a join? Here's a join. I can join this. So I can do like quotes around this, right? So we got that, and then I can join it one more time with something like is not a valid variable type, right? And then so I'll do that. So that's what will come after. Oh, did I just mess something up? Hold up. I did just mess something up. So let's bring these up here. I just cleaned up the thing, so it kind of like pushed these things inside here, and I didn't want that. Alright, so now if you look, if I set like if I go into the console, so it pops up here and I set something, then that will come up. Oh, I didn't have anything there. Let's say I put like float. I don't know. That's not in here yet, so float is not a valid type. So this is just for debugging. This is what I was doing before while I was making this thing. But you don't need to worry about that. So, okay, so let's say we want a ball, and let's say we're not going to use a number, right? We could use a number, but that's not, the point is we're trying to have a ball like move around the play space. So we want an array. So it's going to store like values, right? The X location, Y location, maybe the size of the ball, the velocity of the ball, and the acceleration of the ball. So we're going to set that, and we can make a new list here. So this is why I said that you can just put a list into here. It's really simple because inside the set variable, if you have it as a type array, when you go down to the thing we were just at, this part, the store value, if it is array, see if variable type is array, then it runs through that word that it gets, and that word being this, right? This like string that's from the variable, and it will separate them all and put them into the memory in the right location. So where's okay, so what we can do is make let's say we'll make a ball list. This is going to define a ball. It could be like a class, which in JavaScript is like a template for making that object over and over again, but for now we're just going to have one of them. I also have a demo that I also shared on my profile that shows off making a bunch of objects and having them move in all different directions with different colors and stuff. So I'm basically doing the small version of that. So let's say we want to so we have the list. We're going to clear the list in the beginning, and we're going to have values. So let's say the first value is see, this is what I was talking about. This is going to be here for a long time. Scratch has this weird bug that's like if you wait too long, or if you make objects too many times, or work with a list too many times, then it doesn't save right. I don't know what's going on, but that's going to be there for a while now. Anyway, so as you can see, it adds that. So we're going to want to add like, this will be the X location, the Y location, the velocity, the acceleration. So each two things is for the X. So the X, Y, X velocity, Y velocity, X acceleration, Y acceleration. Then we can have like a friction component, or a friction component and a drag component. If you ever worked with like velocities and stuff, I don't know why I keep doing that. Saving it's not gonna work, but if you ever worked with velocities and accelerations in a game, you know that you know what these two components would do. So I'll explain what they do in a second, and then we can have like a size, which could be like a random value from like 20 to 50, and then we can have a color, I don't know, from 0 to 100. Okay, so. And then also we want to start it with like a random velocity. So actually I'm going to do it differently. The bottom will be X and Y, just the way the stack is going to work with when I make this. I want it to go from the acceleration to velocity to position. So we can have a negative 50 to 50 velocity or acceleration. So this would be like the force in the beginning. When it's created, it will have a random force in a certain direction, and then everything will work out just fine. Then we can say like make ball is a new function, which is right here. Okay, so when we run this, when we run this, right? This is what gets created. So we can see that that ball would have had a velocity in the x direction of negative 43 and a velocity in the y direction of negative 31. So it would have went left and down, more left than it was going down. And then it had a random size and all that, right? And then all we need to do after so we made the ball right here. This was not that hard to do, right? And then you just take the template of the ball and put it in here. So now when we set that, if we look at the memory, then we see there's weird stuff going on here, but basically when you have a name and then you have the reverse bracket, or not bracket, the reverse slash, I forget what it's called, the backslash or something. That's the start of the variable, and then all the way at the bottom is the end of the variable. It's the reverse of that. So it's just saying the start and end. And everything in between is data about that variable. So the first line, this is important actually, when you're reading the values, this is pretty important. The first line is the data type, and then everything after is what's the value stored. And this is going to be important when you start reading the value, because if we look in the cache and we read ball, we get back everything but those top and bottom values, but we get array. And this is useful if you want to check if something is an array or a string or a number, like really easily. But obviously, if we're going to cycle through these and pull out values, we want to skip over the 1. So when we read it, we can just simply delete the first index of the cache. And there we go. And now we can just cycle over everything. So you could do that in the beginning. And we're going to do that in a second. So now we have that. So the cache gets emptied, obviously. Actually, we'll leave it here. But so we have the template of the ball, and then we have the memory stored. Now, what we want to do is we want to do the physics involved with the numbers. So that's going to come in with read. Now, when if we go in here, I have functions like the math function. Where is it? Math variable. This variable, I'll go over at the end how it works. But this, and I think what I'll try to do is I'll put timestamps in the video so that when you look at the play bar at the bottom, you'll see like chunks of play bar, and then you can just go to that, and I'll name them and everything appropriately so that this might be a long video, but it won't be like all over the place. You'll know where to go if you want to look up something, right? So I'll do this at the end somewhere, but this is basically you give it a variable that you want to work with, like ball, and this is only for numbers for right now. I don't have any array math going on here, but if you have like a ball, let's say ball was like the number 5, what you could do, and then you had another, or let's say you had like a variable a, right, and it was the number 5, and you had b, which was the number 7, and you had c, which is number 2, and you had like a bunch of things. Then you could do a plus b times c divided by d, and it'll get you the output of that. Now it doesn't have PEMDAS or anything. It doesn't have like it'll do the multiplication first. It will just go through the list. So if you want to do multiplication first, you would just do something like this. You would just have the b times c divided by d, and then you would go in and say just the end part, which would be that plus a, or you could just do that, right? You could just set it up yourself. It works. It's just a little bit weird, but that's just for numbers. So if we want to work with arrays, we can just do the math inside the cache, and it'll work out just fine. And I'll show you what I mean by that. Another thing is this. This is going to be important because when you add things to the cache, when you read values, you see how it says length 11? When you read another one, it's just going to add to the cache. So you want to be able to clear the cache every time you're reading. And I don't have like an automatic clear cache inside the read function, because what if you're reading a single variable and you want to do like math on 2 variables? Then you have to export that variable's value into like a temp variable and all this weird stuff. So it's better just to have it all in the cache and then clear it whenever you like want to clear it. So let's go into making the physics engine part of the ball. what we'll do is so we read the ball, and these are the variables that we get in the cache, and then let's make a script called calc ball, I guess. And what it's gonna do, the first thing we can do is actually the first thing we do is read the ball, right? We don't want to have that outside the script, so we can calculate the ball so it reads the value of the ball. We can clear the cache as well, so clear cache, read the value of the ball, and then we can delete the first one because we're not going to worry about the fact that it's an array. So we go to cache. Go to cache and we delete the first one. So now if we get the calc ball, then you'll see that here's the ball's values, and the word array is gone. Then what we can do is we can replace stuff. So if you've used Scratch before, then you know how to replace values in a list, right? You just replace. We're gonna want to replace 3 and 4 with, we're gonna first want to replace 1 and 2 in the cache with 1 and 2 times the friction. So we'll do this, and we're gonna get this thing. So we're gonna replace 1 times the friction, and the friction is at 7. So this is basically when you have a force in the real world, or when you have like acceleration and there's something resisting it, like air, it's going to slow down over time. The acceleration is going to decrease over time. Well, that's for the velocity. So that's drag. So friction is more like when you like punch something. It's not like your fist is going to stay with the thing you punched forever, right? You stopped punching it after you punched it, and now the thing is the acceleration it just had is going to fall off. So that's what this is doing, and it's going to be doing it by this small amount, which is good. You want a really small number so that the fall off happens really fast, and you want this long number to happen so it's really slow. So the bigger this drag is, the more it's going to look like it's sliding, like if it's on top of ice, the ball is on top of ice, and this is going to look like the force is like it was like a strong force that fell off fast, or like a strong force that persists. So the more realistic numbers are closer to 0, unless you have something like a rocket that's constantly giving a force with fire, or the explosions. So let's go to 2, and this is pretty simple. You just do 2 like that. And now if we do that, you'll see that the random forces that we had in the beginning got like shrunk down. And then we're going to go on to the 3 and 4, which is just going to be as simple as adding the 1 and 2. So we go here, we add 1 and 2. And remember, when you're doing like math for a list, you have to, there's no like change function, or it's only replace. You can't change the value in any index. You can only replace it, which is a little annoying, but so you have to give the number you want to change here and then do the operation. So there's always like a double thing going on here, right? 1 1 2 2 3 3. But yeah, so what I just did here is I'm taking 3, which is our x velocity, and I'm adding the x acceleration, which is at 1. And then I'm doing the same thing to 4 with respect to 2. Then we just copy this whole thing. And this is going to be basically 3, 4, 5, and 6. And at 3, we're going to multiply 3 by the drag, which is at 8. And then 4 by that. And then 5 is going to be just 5 and 3. And 6 is just going to be 6 and 4. So they're just this clones, but just shifted down 1 or 2 indexes. And 5 and 6 is the position. So now we read from the position to draw the ball. So what we're going to do is I'm going to like stop showing the memory and stop showing the ball. We're going to move the cache here. And now what we're going to do is get the pen operator thing. And we're just going to draw a ball right there, right? So we go here. So we go to, before we do that, the last step you want to do is you want to be able to constantly iterate over the change you just made. So you have to put all the changes you just made in the cache back into the variable. So this is really simple. It's just one thing. You set the value you just had, so the ball, to this. So set ball equal to, and it's again an array. We're working with an array here. And then you just put the cache back into that array, and it will store that value. Oh, I didn't mean to do that. So if we look at the memory, right? So we have the ball here, and then we do the calculations, and then put it back in. Do calculations. Hold up. Why? Wait a minute. Am I forgetting something? I might be forgetting something because these values should be changed. Oh no, it wouldn't. No, it would be changing. Okay, well hold on. Let me first. I'll fix that in a second. But let me first put this part, right. So remember, 5 and 6 are the positions that we set. So 5 is going to be the X position, and 6 is going to be the Y position. So it's going to go there and draw a thing. And we're going to have the size be 7 and 8, right? Not 7 and 8. 9 and 10. So 9 was the... What was 9? So we're seeing big numbers here. So this is the size. And that's the color. No, that's the size and it's the color. Okay, so... hold on. I'm forgetting. So it's size and color, right? So it's 9 and 10. Size and then color, which is going to be set color to this number. So we have the ball. So there, it's showing the ball. The problem is that when we keep calculating the ball, it's not moving. And also, we should be having the erase so that it's not. So when we do the iterative process, it changes. So what am I forgetting? Oh, am I forgetting to... We're replacing the values, and then we're setting ball as an array to cache. I wonder why it's not working. Okay, hold on. I'll be right back when I figure this out. Okay, I made like a very obvious mistake here. So I figured it out. The only thing that I was doing wrong was these are supposed to be from the cache. I don't know why I automatically went to cache when I was working with, well, I was never working with cache in these objects, but I was here, so I thought it would just automatically put cache here. But yeah, these are supposed to all be cache, because I'm working with the values in cache. So the reason it wasn't changing was because the template for ball was the exact same. It was never changing. So it just kept putting the same values in. So that's the only problem. I think it's going to work perfectly now. And then right here, we also have to put cache. And another thing I want to point out here is that everything under this function, I'm still pulling values from the cache, even though we set the variable already. And that's because it's much easier to access the variables we just worked with in the cache rather than setting the variable and then reading the values again, right? If we read well, we don't have a read value from a specific array element. I don't have a function like that, but that would go here, and it'd be more calculations and slower on the computer. So now if we calculate ball over and over again, you can see that it has, well, let's put this in here. There we go. So that's what I was looking for. So let's so you can see all the values being changed, and we can go in here and close that, and then you can just see that it sets to a random velocity and then sends it through the system, or through the, yeah. And then right here we can change these values. So let's say we wanted a much slipperier thing, right? Then it will just slide for much longer. You see that the force is the same, but it's sliding and it goes off the page. Or we can have like a really low velocity, but a really or it's not really low velocity, really low drag, but really high friction, and you see the result. By the way, if these values are there's a property in them where if they equal 1, then the random value that gets put in the ball will eventually go there. So if, let's say, the x acceleration was 10 and the y acceleration was 10, then because these are interchange, or these are like a product of 1, or like if they added up together it'd be 1, then it would go eventually to 10 10. So if we look at ball, you can see that the value it chose was negative 44 and 35. So it had a negative force of 44 on the x and a positive force of 35 on the y, and you can see it ended up going to negative 44 and 35 only if they add up to 1. So like, let's say we had a small number and a 0.9, big number here, then it would slowly go there, but you can see the numbers still match up. We can even have something like negative 100, right? So it's more obvious, more motion. And then we can have something like 0.5, 0.5 back together, and then you can see it goes there really fast, but it still goes there. And then if you switch these, now it's higher here and lower here, the effect actually still stays the same. It's like after you go past 0.5 on both of them, it starts reverting back. So 0.9 and 0.1 is the same as 0.1 and 0.9. But then the more interesting stuff happens when you get numbers that are like 0.15 and 0.999, you know, or like 0.2, you know, and then it's going to go really far and it's going to slide for a long time, right? 0.8, or let's do 0.1, but it had like let's say 0.5. Oh, that's a little too much. Oh, right, duh. So let's do 3. And then, hold on, and then 0.9. I don't know. I was trying to get something where it moves really fast, but it also decelerates really fast. So actually, an interesting thing about what I was basically saying here, if you take the two values, the x and the y values, and you add them together, then that value that you're going to get is basically the distance multiplier of the velocity or the acceleration that you put in. So let's say you wanted to go to 1010, and the total combined number of these two was I just realized, it doesn't really matter, but let's just do that. Okay, that's why the cutoff was there. I had the thing zoomed in and cropped in, or not cropped in, but just zoomed in, because I was trying to get rid of the basically this bottom part and the top part of the screen, just to make it look more professional. But I forgot it's going to take off the sides too, or I didn't really forget, I just thought that it wouldn't be that big of a deal, but I didn't realize how much space was going to be taken off on the sides. Anyway, so let's say you were trying to get to 1010, right? You have a force that's pushing the ball up 10 and to the right 10, and then the total combined velocity was 1, then you would get there to 1010. But let's say the total combined was 2, then you would get to 2020, which is the year it is, which is ironic. Or if it was like added to 1.5, then it would be 1.5 the distance, right? So if you know anything about vectors, you know that like a vector in not the Cartesian coordinate, the polar coordinates, basically we have an angle and a distance to determine where a point is in space rather than an x and a y location. Then you'll know that this distance vector, or the combined, would apply to the distance of the vector that you're trying to add to the ball, or the acceleration of the ball. So yeah, at the time I didn't really think about that. I just knew that them combined to 1 is good, or like that will get you to that same spot. But yeah, if you add them together and they have like a multiple, like 2 or 3 or 4.765, you know, then it's going to go to that point. And another thing is, then if you have a discrepancy, like if it's not, let's say you have 1 and 1 here, then you're going to have the same effect as 0.5 and 0.5, but it'll be double the distance. So it'll be 2020 instead of 1010, right? But let's say you had 1, or like 0.5 and 1.5, then it would get there to the same point, but it would get there at a different rate, like maybe slower, but it would go there. So anyway, now I haven't tested that, but I'm pretty sure that's how the math would work. So you can go test it out yourself if you want. But anyway, that's just a little thing about this. Get back to the video. So anyway, you can mess with those numbers, but that's that portion. Whoops. 0.15. Oh, now it's a little too high. -50. And then if you wanted to have like a physics engine that was you could just apply a force to a ball whenever you wanted to. I keep saving, but this is gonna keep happening. Then you could just make a function where it calls this or it calls the value of the ball, and it applies the force that you want it to have. So we see that this calculation is running forever. So what we could do is we can read from ball, and we can just clear all this, and we can say we want to add to 1 and 2, right? We want to add a force to 1 and 2. And let's just do this right there. Oh, not in that. Trying to replace that. And then this would be 2. And then not that either. And let's say we wanted to add a force of 10 to the right and -10 or 10, I guess. Sorry, I'm used to P5, so upwards is 10, and then we do that here. Oh right, and we have to also set the variable back to cache. Did something wrong. Did something very wrong. Replace 1 cache with. Is cache messed up? No, cache is fine. Read from ball. What did I do? What breaks here? This is supposed to work. Replace item 1 of cache with item 1 of cache plus 10. Delete 1 of cache. So let's do this step by step. So let's take the cache back and let's see. Oh, I see why. It's because it's I think it's desynced. So if we were to stop that, maybe, I don't know, maybe this, and then put it back in. No, that broke it. Maybe it should be fine actually. I don't know what's going on. But let's stop this. Let's read the variable. Oh, right. I see why. I was being dumb. You have to also clear it. I forget you have to clear it. So there we go. Now it's working fine. So it's not out of sync or anything. So if you look, we're applying a force of 10, so it's gonna go up to the right every time I click this, right? So yeah, that's how you would just apply a force. So this little script you would add to like a thing where it's like if we have the forever script, right? We can say we can make a thing called apply force, takes in an x and a y amount of force. That's gonna go here, and that's gonna be these values. And then we can run the apply force whenever the mouse is clicked down. Right? If mouse is down, then apply the force. And let's say we want a force of 0 here, but we want to go up every time. Then what we do is we see this, and then we hold down the mouse, it goes up. Or we can even do something like this. This is where it gets fun. If we have, like, I'll use the up arrows. So we have up, and then we can have down. This could be all. This what I'm about to do could be all part of a its own block, like the player control block or whatever. -10 will be for the down. You can definitely see where I'm going with this. Then right arrow and left arrow. So these are gonna be zeros, and right arrow is gonna have a positive. Left arrow is gonna have a negative. Now I can control the script. So I'm going left, right, up, down. So there we go, with just the arrow keys. And then you have a little game here. So that's how it works. And now, so far, everything that I have done could been done with these guys, with the variables. And it would run slightly faster because there's a lot of calculations involved with finding the location. But I will say that this is pretty fast. It's pretty efficient the way it's working. I'm not searching through a lot of words like a ton, or like how I used to do the JavaScript API that I made earlier. I'm only searching through a word in each letter with this part, with the name of the variable. So the smaller name you have, the faster it will run, but just by barely. and that's about it. But the reason we want to do this is because instead, the way you make like multiple objects in Scratch, right, is you use this function or this thing, the clone. You make clones, right? But there is a limit of objects you can have. It is like, I think it's like 300 clones. And then the other way you would do it with is having, oh, I didn't want to click that, is having just an array, and then you just iterating through the array and saying that for these first 5, it's the ball, or first, what we have was, it was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the first 10 is this first ball, and then the second 10 is the second ball, third 10 is third ball. But this is a lot easier to work with. I mean, all you need to do is make the ball class, and then you do the math behind it, which is pretty simple, and then you just set the thing back into it. Now, okay, so that was that. I don't know how long I've been recording for. 10 minutes, and then the other video was, I don't know. So it's pretty decent of length. So what I'm going to do is I'm going to stop the demo. Actually, what I can have is like a, well, no, I was going to say I can have like a random movement so that something's happening on the screen. Actually, what I'll do is I'm going to duplicate this. I'm going to go to my other project. I'm going to show you the demo I had earlier. This was the demo I had. So it just creates a ton of them. I made another demo before for this, and it would move with the mouse. So it would create a bunch of balls, and then based on the color, it would move faster with the mouse. So the ones that were closer to red would be moving like really fast towards the mouse, and the ones that were on the other end of it, which is also red, you know, the color spectrum is a wheel, would be moving really slow to the mouse. So you would have this like really like pretty design pattern of movement that was based on the color, but the sizes were all different. So it was really like good, but because of this weird bug that's going on, I worked on it for too long, and then I saved, it didn't work, and then it tells you to download, and when you download it, because of this weird bug that's happening, you download a corrupted version of it no matter what. So right now this button doesn't work. Basically it downloads a really broken version of it. Okay, so let's do the let's see. Okay, so we saw this clear cache. Actually, what I'm gonna do is I'm gonna, well, for now I'll leave this, but I'm gonna have to clear all this out because this is just supposed to be the API, and I don't want all this junk getting in here and everyone has to delete it if they want to use this. So we saw the let just does set but faster. So again, maybe I wasn't clear before, but you can't use let to like set a variable again, right? You can only do it once. So if I let ball here and then I let it to a value, then I run again and say let ball to a value, then it says it's already declared. So watch, if I go to the console and I do like, I don't know, dog, and it was an array of something, but let's just say it was a value of like 50. Oh, so you could write your own thing here, right? So your own array. So it was like it had 3 values, all of 50, and then I let it, and I let it again. Oh, I thought I had the, oh, let is broken. Why is let broken? If item, oh, I see. Let is broken because of that property thing. So if I reset this, yeah, there we go. I guess that messed up. That's weird. Oh wait, it was that, hold on. If I have that back, is this, no, it stays the same. Okay, at least it stays the same. I thought it was creating variables over and over again because I didn't have this in here. But so anyway, you saw what happened when I let dog once. It adds it to the thing, so we can see there's the dog array. It has 3 values of 50 and 50, and then you see I declare again. It says dog has already been declared, and that's because the script's only this. Then the set variable is this new thing, and then letting it. So I'm basically clearing out the old one, and then yeah, a lot of weird stuff. So set variable links, hold on, delete. Okay, so that's doing it right. Yeah, so you can see set is not that much bigger. I'm just basically the size of the variable for whatever you're setting. So as in this case, the variable is from this point 14 to 19. Let just does that many actions, whereas set does that many actions twice. So it's 2 times more calculations because it's deleting all of them and then it's setting it again. So there could be other ways I could do it, but I think the majority of it is the fastest here. So yeah. So let's go to looking at the math function. I kind of showed it off already, but let me do a memory wipe. Right, so if I do this, it's gonna have another ball, so I don't want to do that. We have a memory wipe, and then we're gonna let a few variables. We're gonna let a, it's gonna be a number. Remember, this math variable only works with numbers. If I set it to an array or a string, it can break. You can have infinite loops sometimes. It could do some weird stuff. So you only want it to be a number. Then let's set a to 10, and then let's set b to 5, and then c to like 3. So we have the memory wipe, and then we let these. There we go. And then we can do something like we're gonna set a, or we could even set it to d. Like let's make a new one. To d, it's gonna be 0, right? So we can do that again, and now we have a variable down here called d, and we're gonna say d is gonna equal, what was it? So we can have a times b, which is gonna be 50, and then plus c. So d should be 53. Okay, there's a problem that I'm seeing. Doesn't exist in memory. Okay, so I have a problem. It worked, but I have another error happening, and that would be part of the math part. Do I have it where it says name somewhere weird? Set variable name. I wonder why that happened. Where is the part where it says that? I don't know where it even... Set variable doesn't exist. Name. That part is in set, I think. I believe that's in set. Or well, it would be in let, which is... No. Why can't I find my own code? Somewhere here it says, right here, is not a valid name. So variable type. Did I make it? Hold on, did I make something wrong here? No, they're all numbers. So what happened here? Variable type comes in. If variable type is it's a number, then add it to memory. Why did that happen? I'm so confused. That is so strange. Okay, I'll fix that in a sec, but you can clearly see that the math works here. And also, by the way, you can have as many spaces as you want in here. The value is going to happen the same. So if I were to like set this to, 10, then you're going to see it's going to be 60 here. Gosh, memory wipe. Yeah, there we go. I had to reset it. So you'll see 60. So that's a neat feature. So if you have ever programmed in Java, you're used to doing like a plus or space plus space b space plus space c, stuff like that. And you see that got 25. So the 4 operators that I have inside here is addition, subtraction, multiplication, and division. I can add modulo, and I could add this thing, the power of and stuff. I could add that, but for right now I don't have it added. But I could do that. And so that's the math variable. No, I'm trying to think. Is that all of it? I feel like there was a couple other things that I wanted to show off with this, but I'm not sure. I guess the string. I mean, it's the same thing. You're not gonna be able to do math. But let's say you had string, right? And it was. I mean, you can have a string called 10, I guess. And I think the real reason that I had this was like, my initial thing was for the checking thing. Well, my initial reason I put that in was because JavaScript uses it, right? And I'm kind of basing a lot of this off of JavaScript. But then I thought the reason for that you would have it for Scratch would be something like if you're having a bunch of variables, like you have a list of a ton of random things. You have arrays and strings and numbers and all that stuff in the cache, and you wanted to only pull out all the strings. So you had a memory, like you had a ton of information in the memory. You cache it all, and you say, I want all the strings, then you go to each string and get all the strings, right, in the cache. So that would be like a nice way. You could check which ones you want. Instead of having to go to the number 10, like you get the value of 10 and you have to check, well, how do I know if this was the word 10 version of number, right? So like something more like this. So yeah, that's how you do it. Let me put that 10 back. Oh, and another thing about the math variable is that it uses the cache to do its math. So if I show you the output D of this, and I'm reading, so I'm basically clearing the cache, then I'm reading the value, which if I just do this, you'll see it's a number and it's 40. But then I'm deleting that. So you'll see it's 40. Well, if I do the math again, you'll see that the cache disappears. And that's because it had to use the cache. So it's okay that it clears the cache. It's okay that the operation does modify the cache, because you would only be using the cache to like change the values in some way and also read it, obviously. But then you could just do what I did here. So you could see that if I just do this, it works, right? So the math, then you clear it. Well, it already clears, so I don't need to do that. But you do the math, then you read the value, which is the number 40, and then I can just delete the first one. And so it's basically a trade-off that gets you the same output as if, but it's like nice and easy to do this, right? And the only other way you would do it would be to do something like this, where you had A, B, and C. So you read the values of these, right? Oh, let's clear the cache again. So you had I forgot oh right, I had to do that. So you got a number, 10, 5, 10, and then you would pull 2, 4, and 6 out. Or what you could do is you can, I guess I could have the read value input a variable. You know what I'm going to do? This is going to be a huge change, or not a huge change, but this will be a pretty good change. Is instead of adding to the memory in all these spots, what I could do is, instead of add, I can insert at one. No, I don't want to do that. I just realized I don't want to do that. Yeah, I don't want to do that, because then the array will get changed. So instead of the array coming back as the order it was put in, it will come back reversed, and weird stuff will happen. And then the number word will be below yeah, that would have been weird, but I was gonna insert at the top the low number chunk. So never mind, I won't do that. But then you had to do that. This, pull from 2, 4, and 6, and then do your operations, and then you would have to set back that value, which is just very manual. It's faster, maybe, but it's manual. Oh yeah, it is faster because I'm having to read through this and compile it. Anytime you're turning text into operations, it's some. Okay, I don't know if I cut there or not. But yeah, someone walked in my room. So anyway, I don't know what I was saying. Oh yeah, the operation. So yeah, anytime you're running through letters like this, or words, and you have to compile each spot, and it's more calculation. So this method would be a lot more. It'd be a little bit faster, maybe a decent amount faster, but it's a lot more manual. So you could do that. So anyway, yeah, that's the whole API. In theory, I think if you're working with situations where you're doing a lot of variable manipulation, and you're making new variables, and you have this just sort of chaos, this kind of puts order to that chaos. This system, it makes it a lot easier. And I'll fix this. I just realized I still have that there. But yeah, it puts a lot of, it makes it a lot nicer. In the past, I've tried working with ways to store values that are like an array within arrays kind of thing. So it's, how do I explain this? Like, if you wanted like an image, right? An image is a matrix, and a matrix is a two-dimensional array. It has values going left and right and up and down, or well, values going up and down and left and right, because these are going up and down. In JavaScript, you would most likely see an array kind of put out left and right, but you get the point. So it'd be an image would be like a 2D array, and to do that, it's pretty simple. You would store an index in the array as the array itself. It would be something like this, right? So remember how I said you could take this thing and you could put it in to like a value? So then what I could do is I could just if I go to the set thing, so let me memory wipe, right? And I'm gonna have a, and we have the cache here, and I'm gonna set a as a string. I mean, it doesn't matter, but this will technically be a string because it's gonna be a word here as well. I'm so used to doing stuff like that. So then what we could do is, well, we could just put that here. Oh no, well yeah, and boom. Now we have. I was gonna get the set function, but let is fine. So there we go. We have this. So let's say what we could do here is I could actually write to the cache. I could say I'm going to delete everything from the cache, which is just to clear that. I'm going to add to cache. And the cache is going to have a value. Let's say you're working with a grayscale image, and first spot is 10, and then 50. Let's say it's a 3x3, and then 1. So these are from 0 to 100, let's say, brightness. And then that will be put in to that spot. Let's even make this an array, actually, array. And, well, no, we couldn't do that. It would be a number. Well, it would be a string. Anyway, you see how it stores that section. Then you would go to the next line in the code, which would be, we make B. We could just do this multiple times, I guess. And then C. So now you would have a 3x3 image here, and all you would have to do is read from A, which you wouldn't name it A, you would name it like row 1 or something, or X1 or something like that. And then you could iterate over all of them, and you would store it like that. Or you can have the array be something like array, let's do A, memory wipe. If I just did this, then yeah, you can see how it pulls out the 10, 50, and 1. But let's say I wanted the 10, 50, and 1 here. This is how I would do it, actually. I'm going to clear the cache again, and I'm going to set the cache equal to this. All right, it's going to be 20, 50, 60, 10, 100, 80, and 30, 50, 40. So this would be your image, right? It'd be a 3x3 image. You would add that, and then you would memory wipe. Oh wow, I forgot that does that. Just pretend that I actually, you know what? That's an interesting thing. I guess I could add this in a functionality to make sure that you change. Yeah, there are ways I can do this. I can basically, if I had like a system that was dealing with this stuff, I could do stuff like this, where it would put brackets around it, and then the system would be like, okay, if there's a bracket here, then instead of going through each one, just do the whole thing. But that's a whole annoying process. Anyway, yeah, I'm going off on a whole tangent here. That wouldn't be necessary to do that. It just kind of pulled it out in a big string. Actually, the thing about this though is that when you're actually working with images in like real computer code and stuff, they're not really stored as an array of an array, like multiple arrays, right? Or like a matrix. It's stored as like a long single array, and you just do some math to figure out which spot it is. So you would, for the X position, you would mod 3, meaning that well, you would mod 3, and then in Scratch you would add 1, so that if you had a number X, or you had a number I, let's say, and you put it into that function of mod 3 plus 1, then it would be X. For X is 1, it'd be 1, then X is 2 is 2, X is 3 is 3, and then X4 would be 1 again. But then to change the Y, you would take the floor of that modded value plus 1, and then you would divide it by the width, so divide it by 3, and then some. You do some weird stuff. You can just look it up online. It's pretty easy to find that, and then that's it. So you have a single. You would have this thing, but you would read the first 3 for the first row, the second 3 for the second row, and third 3 for the third row. So there you go. You can store images in here, and actually that is probably faster to do than pulling out. Yeah, that's actually faster. So this is actually better than I thought it would be. Anyway, I'm gonna clear this all, but that's basically it for this tutorial thing. It was more of a demo with a little bit of instructions, but I gotta do this in such a way that it. Oh gosh. Okay, so hold on. I gotta clear this first. Then I gotta clear this, and this. I believe that is all of the nonsense. Okay. I'm surprised that it's saving again. Oh, you know what? I haven't left. I just realized I haven't left this project. And the failed to save went away a few times, didn't it? So I guess you just gotta wait a long time and it eventually works. But yeah, so yeah, that's all it. If you come to this project later, like much later after I made this tutorial, right? This might look different. And if it's different enough where it's confusing and there's like features that look like would be useful but you don't know how to use them, then just go in the comments and comment down, make a second tutorial or something like that, and I'll do it. I'll definitely do it. Or I could just respond right then and there in the comments. But yeah, that's basically it. I hope you enjoy this. It was fun making. It was definitely pretty fun making this. I enjoy making these kind of things where it's like the foundations. Actually, you know what I want to do is I'm going to erase that so that the actual... Oh, and then I got to do this. So there we go. Now I can save, and then it's back to the beginning where you would see this kind of nice pattern thing. That's just because I just do this just because when you look at the project, you don't see something like this. You see actual things. I did that similar for the JavaScript API. By the way, this one sucked. Like it works, it converts well, but it takes forever to do. Then I did the JSON one that does convert, but and it's faster, but it also takes forever to do. Here's like a demo I guess I made with it. Look at this. So this is 20. So there's 20 objects here. And look at how slow this thing is. In the other one I did, look at, if I go to the, oh, here I can stop this and I'll just go to this. In this demo, look at how many, there's 50 here, and it's just smooth. And not only that, but the other thing was just random motion. It was just taking one value and doing random motion, I believe. Whereas this was the X position, Y position, it was the X velocity and Y velocity, and it was the X acceleration and Y acceleration, and it still held up true. And that's because I'm only using the actual lists indexes to manage all the values in each variable, rather than in the other one. Let me show you how I did this. It's disgusting. Wow, I had a long thing here. Okay, so yeah, just look at the size of this thing. Before I even show you what's happening, like, look at how many steps I'm taking to deal with this. So yeah, look, like, basically, if you know JSON coding, or like how a JSON object is structured, it's a lot of brackets, or curly brackets, and then you have like an item in it. This is called name, and it's set to, and I have it actually being set to the username. I don't know where I do that. Yeah, right here. So I'm writing to item name with the value username to the object player. So this is the variable player. So this was more of a, you can set basically an infinite amount of variables to one variable, because that's how JSON works. You can have like a package set to a variable, where the other thing, there's no packages. It's just numbers, arrays, and strings. So it would be, the other one would be like JSON, would be like one of the other variables in JavaScript, but in mine it doesn't have that. And basically what I'm doing is I'm going through every single letter from each curly bracket, from one part to the other, or from beginning to end. And I have so many variables that are well, not so many, but all these variables managing each thing. So when I go to a curly bracket, it's like, oh, you're in a score 1 of curly bracket. You're in one object. You go to the next curly bracket, and now you're in a score 2. So meaning this is a whole nother object right here. The X and Y location object inside the location item inside the player variable. And you could go on forever. So in JavaScript, they handle this differently, and it's really nice and clean, and it's fast, and it's so. I'm pretty sure in JavaScript the way it handles objects is it's more like it creates names, it creates variables for each of these items, and just references them. It's way faster than I did. I'm actually going through the actual text about them, and then I'm like, okay, so now I found where X is, so then just copy everything. So go again through the system, copy everything up until that location, then like if X was like 470 something, then you would just skip everything there until you get to this comma, then make a new one. So that's like compiler B, or like segment B right here, this variable right here. So it stores A and B. If we look at A and B, actually, I think you would see it. Yeah. So we're changing the name, so you get everything up to the name, and then you get everything after that, and then you just combine them, which actually that doesn't look like everything after that. Looks like it's missing something. It actually looks like it's breaking. I don't know. I guess it doesn't. I don't know. Anyway, look at how many calculations. I have a calculation counter in here. Basically, that step took 469 calculations, which you don't like. It's hard to like know like, oh, is that a lot or not? But when you have, oh yeah. So wait, can I move? Yeah. Okay. So so there is a demo in this. So I can move around this ball, and you can see it's managing it all, and it seems like it's fine. Look at, there's one ball. It's managing all, and so this variable holds every information you need to know about the player, and it's great. There's a ton of calculations happening. Actually, by the way, if I take this off, and I see the 469. The previous one that was called JavaScript API or whatever, the one before this that had like the P5, or no, not the P5, that was another one. The JS with a yellow box. Doing the same, I have the same thing set up. I actually probably could show you, and takes like 1,000 something calculations, right? So this one was faster. This guy was faster, but it's still just atrocious. So here, if I go in here. Okay, so I'm not showing the ball, but you can see the name. Okay, so look. Let's find where I do the calculations, right? It would be somewhere under the. Oh my god, this one's such a mess. Okay, right here. So we have the same value. We have the same thing. Name, temp, location. If you look over here, it's name, temp, location, all the same thing, right? And then, but this one, it do one more step, I believe. And then we're writing to the name, username, and there we go. Writing name, and then look at how many calculations it took. That was not 1,000. This is 1,500 or 157,000. So this was really slow, and it's because I didn't take any shortcuts. I went through the thing 1,000 times basically. Went over every letter. So yeah, it was just nonsense. And then I figured out how to fix it. Like I don't even know how long later. If I look at if I go in here and then go in here. This is not going to be a good estimate, but let's say, okay, July 30th, so not that long ago, and then August 1st. So, wait a minute. July. Huh? Hold up. July. Isn't that the next day? Or 2 days later, next day? Am I being stupid? January, February, March, April, May, June, July, August. Yeah, that's like literally the next day. That was only like a month ago, too. That's so crazy. I guess maybe I don't even know. Maybe I created this and this. I don't even know. Maybe I did that whole thing in one day. That would be crazy. But I figured out how I do it better, and it's only 469 calculations. But we all know what's better right now, which is this. This is much better. This has, even though it doesn't have JSON, it stores values in an array. So you would just, all you would have to do is, instead of looking up a name for the index, so like you don't have to name it X. I mean, you do name the things, right? Well, anyway, I'm going off a whole tangent. I guess this whole part will just be like called nonsense or something in the progress bar at the bottom. But yeah, the video is basically over at this point. It's been over for a while now. Anyway, thank you for watching. I hope you enjoyed. I'm pretty happy I've made this video. I've noticed that on my YouTube channel, there's one video in particular that just keeps getting views. For a channel like mine, is pretty interesting because like I mean I have 26 subscribers. I think maybe, I don't know, 3 weeks ago I only had 20 or 21 or something. So it's actually been doing pretty interesting stuff recently. And I've gotten a few comments about this video in particular. But yeah, if you look at this video, 324 views. It's been up for 7 months, but that's still pretty interesting. Most of the views, I'm not gonna go into analytics because I'm pretty sure that's against YouTube's terms and service and stuff like that, or creator policy. But I will say that the majority of people that watched this video were like, they watched for 3 seconds and gone. Could be robots and stuff. But I did notice that a lot stick to the end, and it's, or not a lot, but a good amount stick to the end, and it was like an hour-long video. What the heck? Who stays to listen to me for an hour? That's just but it was very flattering. I found it very flattering, and so yeah, so it definitely motivated me to make another video. Well, actually, it motivated me to make another Scratch project, and then I decided, oh, it's working out pretty good, so let me make a video on it as well. So yeah, so that's this video, and again, for like the 7th time, I hope you enjoyed, and thank you for watching.